All right. Welcome to Office Hour 6. You may hear the UAB drum line in the background. I don't know. This week is mainly about gases. Some of the stuff's kind of straightforward, and some of it should be a little familiar to you, since you do have some experience with gases. The first part of Chapter 8 is talking about what pressure is, and it's force per unit area, and you should get an understanding of why there's air pressure above your head. Basically, it's the weight from the force of gravity of all that air above your head. And when it's spread over a certain area, it's kind of more or less same most places around the globe. Of course, the higher up you go, the less air there is above you, the lower the air pressure is. Section 2 talks about Boyle's law. Now, you don't need to know the names of these guys for the exam. You just need to understand how the gas behaves. And so if you keep everything constant, that is to say the amount of gas and the temperature of the gas, it turns out there's a relationship between the pressure and the volume, is that the product is a constant. So an example would be like a bicycle pump. There's a piston inside. As you push down and you compress the gas, the pressure increases, and so as the pressure increases, hopefully the pressure is greater than what's inside the tire, and air will go from the pump into your tire. All right, and so the next section is talking about another relationship, and that's between the temperature of a gas and the volume of gas holding the pressure constant. And the example there is a hot air balloon. Basically, you heat up the air, it expands to a larger volume, and because there's a larger volume, the air is less dense, and that's how the hot air balloon floats. The Section 8.4 talks about the relationship between temperature and pressure. And so, for example, if you buy a spray can that says don't throw in a campfire, because if you heat up the gas inside, raise the temperature, the pressure inside the can increases, and it will rupture. The other thing is that's the section where they talk about how the boiling point of a liquid is related to the vapor pressure. Any liquid will start to boil when the atmospheric pressure is equal to the vapor pressure. And so for water at sea level, where the atmospheric pressure is about 1 atmosphere, then when the vapor pressure of water reaches 1 atmosphere, it starts to boil, and that happens to be at 100 centigrade. Now, at higher elevations, the air pressure is lower, and so water will not boil at 100 degrees C, but it'll actually boil sooner. And so that's why you need high altitude directions for baking cakes and so on. Then Section 5 talks about the combined gas law. Basically, it combines all these ideas. So PV being a constant is this case where the temperature is the same. Here TV relationship is where the pressure is being constant. Here the pressure and the temperature relationship is where the volume is being held constant. And so you need to know this equation in the blue box. I'll give it to you, but you need to recognize when you need to use it. And so you'll be given a couple of different pressures, like before and after something's been done, or a couple of volumes, or a couple of temperatures. So basically you're going to need 5 of these 6 variables in the problem. So if you see more than one pressure mentioned, you're probably looking at this kind of problem. The only requirement is that the pressure needs to be in the same units, volume needs to be in the same units, and temperature needs to be in Kelvin. There's no options about Kelvin units. You can't leave it degree C. Then the next section is Avogadro's law. Now the equation they use in that I'm not going to have on the exam. So the equation they use doesn't really specify a temperature or a pressure, but I will. And so since I will, that means you can use the equation in the next section, which is the ideal gas law, PV equals nRT. And so this is an equation that relates the pressure and the volume, the number of moles of gas, and the temperature in Kelvin, and those are all related to each other by something called the gas law constant. And in the units of liters for volume, atmospheres for pressure, moles for the number of moles, and Kelvin for the temperature, this number is 0.0821. So I'll give you this equation, I'll give you this constant. Okay, so you'll be given all these equations, this one, and you'll be given this relationship if you need it in problems. So let me go back to Avogadro's law. So what you can do is you can calculate that the volume of a gas at the standard temperature and pressure, which is 273 Kelvin, 0 Celsius, and 1 atmosphere pressure is 22.4 liters. It doesn't matter what the gas is. So 1 mole of nitrogen is that volume at STP, and 1 mole of hydrogen, 1 mole of oxygen, whatever. Now the requirement to use this equation, if you're given 1 pressure and 1 volume and 1 temperature and 1 number of moles, or at least 3 of those 4, you need to have the same units as the gas law constant you're using. So the textbook actually has a different gas law constant where the pressure is in millimeters mercury. I'm not going to use that. You could always convert millimeters mercury to atmospheres and use this equation, and that's what I expect you to do. Then the last section is a simple idea, but it's difficult for some students to grasp. It's the idea of partial pressure. So if the pressure in this room is 1 atmosphere, and air is made up of 80% nitrogen and 20% oxygen, well, 20% of the collisions that give a pressure are coming from oxygen molecules, and then 80% of that pressure is coming from nitrogen molecules. So they more or less don't even know that the other gas is there. And so what that means is you can just add the individual partial pressures. So 80% of the pressure in the room is from nitrogen because it's 80% of the molecules in this room. And the total pressure is just the sum of the partial pressures. And the last thing I want to do before I take questions is to kind of work a problem using stoichiometry and kind of give you a hint of how to recognize, should I use this equation, should I use that equation, should I use that, and whatever. Okay, and so this is question 858 in the text. So how many grams of ammonia can be produced from 4 liters of nitrogen? So notice it's 2 different compounds here into a nitrogen. So that means we're going to have to do a mole-to-mole conversion using the balanced chemical equation. So keep that in mind. So now the other thing we have to recognize, not only there are different things, but there's different quantities. How many grams of ammonia? So this is the volume. Okay, so there's a clue. I might need to use one of those 2 equations, but which one? There's a temperature, okay, and there's a pressure. Okay, so I'm going to be using this equation for 2 reasons. One is I don't have 2 pressures or 2 volumes or 2 temperatures, so I can't use this equation. And the other is if I use these 3 variables, the one I don't know is number of moles, and number of moles is precisely what you need to do a mole-to-mole conversion. So let's go ahead and make sure that the temperature units are in Kelvin. So 273 plus this, 688 Kelvin. And then this pressure has to be converted using the fact that there's 760 millimeters of mercury in 1 atmosphere. So let's go ahead and do that. So that's 0.954 atmospheres. So PV equals nRT should give, if I've done it right, and the students in the class this morning I think did it right too. N is 0.067 mole of nitrogen. Okay, so remember we had the volume of nitrogen, the temperature of nitrogen, the pressure of nitrogen, solving for the moles of nitrogen using PV equals nRT. So the PV equals nRT was all for nitrogen. And now we do a mole-to-mole conversion using the chemical equation. Sorry, it's not, it's NO. My bad. NO. NO. All right, so convert 4 moles of that to the other. All right, so let me do some erasing here. And put it up here, nearby. And maybe you can get ahead of me, who knows? Could happen. All right, so 0.067 mole of NO. Then there's 4 moles to 4 mole. NO to NH3. So it's kind of trivial. It's 0.067 mole of ammonia. Then the question is how many grams? So we need something that converts grams to mole, or moles back to grams. And that's the molar mass. So 1 mole is 17.0 grams. So the answer is simply the product here. 1067 times 17. 1.14. Okay. So notice how this mole-to-mole thing's based on the chapter 7, and this part, the PV equals nRT, is based on chapter 8. And so this stuff does accumulate a little bit. That's why it's kind of presented in the order it is. All right, Duncan, I'll be taking questions now. Final exam is a time period covering August 4th would be at 8 in the morning, and then through basically midnight, which means you need to sign up to take it before 10 o'clock that night. So that's when the final is. How do you check if you're the workshop leader for the week? That's a good question. Email Sathira at uab.edu. He's the person who made those assignments. I don't know where he put the list or how he sent the list, so ask him. Somebody asked last week about getting grades on the recitations, so he started assigning numerical grades. More or less a rough scale that I gave him. Oh yeah, somebody else did ask about the final. There will be a little bit comprehensive from the first half of the semester, about 1/3 maybe, and about 2/3 will be the new material. By the way, I did not check and see if all the quizzes add up to 120 points or not, but it doesn't really matter. I mean, if it does, it's just to your benefit. It's like 20 extra points. Let me check into that. So it doesn't show, the ProctorU doesn't show the exam as being something they can sign up for yet. Let me check on that as well. If the student who actually asked that question, if you'd send me an email, I'll try to respond to the whole class with that answer as well. One student did notice that there was a slight error in the video on heat and chemical reactions, that basically I forgot to divide by 2 at the end of the video. So I reshot that video. I'll have to edit and repost it, but just take note of that. If you were puzzled, that's a good thing, because I forgot to actually divide by 2, even though the 2 was there on the screen. Do I look any older? I had my birthday yesterday. I'm 25.